For our next example, I would like to start by getting a 1 in the first equation for the x coefficient. Now there's two ways of getting a 1, and the way we can use on this particular problem to get the 1 to be in row 1 is I notice that there's actually a 1x in row 2 already. So if I simply take row 1 and interchange with row 2, I can get the 1 in the first equation in the x spot just by switching the two equations around. So I now have the 1 coefficient in the x in the first equation. Hooray! So the next goal is to get a 0 below it. Now to get a 0 below it, remember to get a 0, I take the opposite sign of -3, which is +3, times the row with the 1 in it, that's row 1, the one I just got, and add it back to row 2. This is the step where I have to do some work, so I'm going to multiply the whole first row by 3. So that gets me 3x minus 6y equals -15. And then I put row 2 right below it. And I get the 3x's to add to 0. No big surprise there, that's what I was hoping to have happen. What accidentally also happened is my y's added to 0. And then over here on the variables, -15 plus 15, also added to 0. So row 1 stayed the same. And row 2 I'm replacing with 0 equals 0. Well, I can't very well get this 0 to become a 1y because it doesn't have any y's there at all. I notice that this is a number statement, and so because it's a number statement, I look at it and I see if it's true or false. In this case, it is true. 0 equals 0. So this is going to tell me I'm going to have infinitely many solutions. How am I going to find what the solutions are? Well, I'm going to use back substitution. Now, when I use back substitution, I'm going to let y equal any number. Okay? If I let y equal any number and solve for x, that's going to get me my answer. So y is going to be any number, and then the x variable is going to be an expression in terms of y. So to get that, I'm going to take x minus 2y equals -5, which is the equation from my last manipulated system of equations, and I'm going to solve for x. So I'm going to take the 2y and put it to the other side. If I take the -2y and move it to the other side, it changes signs from -2y to +2y. Notice everything else stays the same. X was positive and it stayed positive. -5 was negative and it stayed negative. Transposition is pretty easy. You just take one term, put it to the other side, and it changes sign. Now that I have x solved, I can plug that in for the x spot. This is the answer for every single solution that will solve my system of equations in terms of any number we pick for y. We have one last problem here, and we're going to use a word problem. At a secondhand clothing store, we have 10 shirts and 20 pants were sold for $400. Now the next day, sales were slower, and the store only sold 4 shirts and 15 pants for $265. Determine the cost of each item. So to find the cost of each item, we're going to let x be equal to the cost of one of the two items. In this case, we'll say shirts first. So cost of a shirt. And then y be the cost of a pair of pants. Okay? I have two data points here. I have 10 shirts and 20 pants sold for $400. So that's, and if I write that in an equation, that gets me 10 times the cost of a shirt plus 20 times the cost of the pants, which we say was y, equals 400. I've got another set of data here. We have 4 shirts and 15 pants. Cost $265. So if I write that equation, that gets me 4x, 4 times the cost of the shirts, plus 15 times the cost of each pants equals 265. So now I have a system of equations and I need to solve it. The first goal is to get a 1 for the coefficient of x in the first equation. Now I can't switch the two rows, that's not really going to help me get a 1 there, so I'm going to choose to take my row 1 and multiply it by its reciprocal. The reciprocal of 10 is 1/10. So if I take 10 divided by 10, that's x. 20 divided by 10, that's 2y. 400 divided by 10, that's 40. Notice that the second equation doesn't change at all. I just bring that down. So step 1, I got a 1 exactly where I want it. Step 2, I want to get a 0 below it in the x coefficient of the second equation. So I want a 0 there. Now remember zeros? To get a 0, we need to take the opposite of positive 4. The opposite is negative 4. Times the row with the 1 in it, which is row 1, and add it back to row 2. Okay, so row 1 stays the same. And row 2, this is going to take a little bit of effort here, so I'm going to multiply everything by negative 4 and use some scratch paper over here. So I have 4x, negative 4x, minus 8y equals negative 160. Then I put row 2 right up underneath it so I can add the two rows together. So I get 15 minus 8 is 7y, and 265 minus 160 is 105. So I replace this with 7y equals 105. Next, I want to get a 1 where there's a 7y. So I want a 1 here so that I have 1s down the diagonal. So to get the 1, I am going to take the reciprocal, which is 1/7 times row 2, put that back into row 2. Notice that row 1 is going to stay the same. And I'm just going to multiply by 1/7 to both sides. So that gets me y is equal to, and 105 divided by 7, if you need to, you can take a calculator out, is going to be equal to 15. At this point, I can now back substitute to find x and y. So I know y is equal to 15 because the second equation says so. To get x, I have to take x plus 2 times y equals 40, but I know y is now 15. So now I can simply solve for x and get x is equal to 10. So what does this tell me? X was the cost of my shirt. Do you remember that from way back in the beginning when we wrote our variables in red? The cost of the shirt is going to be x, which is $10. So y, which was the cost of my pants, is going to be $15. So that's the cost of each shirt and each pants. Now we have a part B to this question. It says, how much revenue would the store earn if they sold 20 shirts and 16 pants? Let's say the next day they sold a different amount. So if they sold 20 shirts at $10 a pop, so 20 times 10, that's going to be $200 of revenue of shirts. Plus, if they take 16 pants and multiply that by the $15 per pants, they're going to get $240. Again, if you need to use a calculator, go ahead and get one out. So the cost of 20 shirts and 16 pants, if I add the 200 and the 240, that gets me $440 for 20 shirts and 16 pants. So that's how we can use systems of equations to solve a word problem using the echelon method, and then we can extrapolate information. Well, what if we sold 20 shirts and 16 pants? We can solve for that. And this concludes our lesson on solving linear systems of equations using the echelon method.